Inside the ventricles, we have some ridges, some elevations that we call all these elevations Trabeculae Carneae. So inside the ventricle is basically bumpy. Then we notice some of these Trabeculae Carneae are tall, and more importantly, they are connected to the AV valves. We have some structures. They have the structure and strength of, for example, tendons. That's why we call them Chorda Tendineae. What they do, they attach the tall Trabeculae Carneae to the AV valves. We named the tall Trabeculae Carneae that are connected to the AV valves papillary muscles. So, as a summary, we have the actual bicuspid and tricuspid valve, and we see that their cusps by Chorda Tendineae are connected to the papillary muscles. What is the use for papillary muscles and Chorda Tendineae? When from atria blood flows into the ventricles, while ventricles are receiving blood, we know that the wall of ventricles stay relaxed. So all these muscles, including papillary muscles, are relaxed. However, when ventricles start contracting, we know they push blood up, and that's the moment we definitely need AV valves to close to prevent backflow of blood from ventricles into the atria. However, because ventricles are very strong and they generate lots of force, it's always possible that when they push blood up, at some point, they make AV valves open upward. That would result in blood from ventricles go back to the atria, and we don't want that to happen. So we want to make sure that when AV valves close, they stay closed during the entire time that ventricles are contracting. So when we say ventricular walls contract, it means all these ridges, all these muscles contract, including papillary muscles. And we know muscle contraction simply means muscles become short and thick. So imagine when ventricles contract, papillary muscles are contracting too. They become short and they pull down these Chorda Tendineae. Basically, Chorda Tendineae are like some ropes that are connected to the AV valves, and they are pulled down, they are tightened to make sure AV valves stay closed during the entire time that ventricles are contracting. So in short, while ventricles are relaxed, papillary muscles are relaxed too. They are not pulling down Chorda Tendineae. We can say Chorda Tendineae are kind of loose. However, when ventricles contract, the papillary muscles also contract. They start pulling down, tightening the Chorda Tendineae, and Chorda Tendineae are attached to the AV valves. What they do, they make sure that AV valves stay closed while ventricles are contracting.